Hello YouTube. In this video I'm going to go over how to test your electronic components, your electrical components before you assemble your ANET88 3D printer. This is an important step to do because you don't want to assemble the printer just to find out that there's a bad part and you have to disassemble the printer so you can deal with your vendor on trying to get the part replaced. So it's a good idea to test everything out before you start actually assembling the printer. That being said, don't be intimidated by all the stuff. We're going to break this down and go over it, hopefully piece by piece. There's a lot of parts there, but we'll step on. First, I want to talk about a little bit about some upgrades you should do right off the bat. And there's a lot of loose wire connector ends, and I highly recommend getting these blue crimp-on connectors. They're meant for blue in the States is meant for 16 to 14, or you should say 14 to 16 gauge wire, and that's so it looks like what all these wires fall in that range there. There's other colors for different gauges, but this seems to be the most appropriate. And just an example, all these wires here were just stranded wires, and I noticed that they started tinting the ends on their own. I didn't have to tint them, and but the idea was you'd put the wires in here and then screw them down, which isn't a good way to do it because the wires will tend to fray out as you screw them down. It's just not a good connection. So by using the crimps on there, you get a nice firm connection. Another thing I recommend, if you can, you should go out and actually get some real crimping tools. Don't get those cheap little ones that everybody buys with the little kit. This is a ratcheting crimp tool, and I don't know if you can see right there. See, it's got the color codes. Those are the different colors for different gauge standard wiring. You got the red, the blue, and the yellow, and again we're using the blue. And these are ratcheting. So you put the crimp into the ratcheting, and you'll get a perfect crimp on every time, unless there's something wrong with your crimper. And so I highly recommend using that setup there. Also, if you do need to strip some wires, a good set of wire strippers, you can find most of these kind of things at an auto parts store, a good auto parts store. Don't get the cheap ones, just get some decent ones. Again, the ratcheting tool, you're looking, I don't know, around 30 bucks for a good one, and then the stripper's probably around 20 bucks. I also recommend you just get a good screwdriver. They give you one which is nice in the kits, but they'll work most of the time, but they're just not a good tip. They're kind of cheap. And let's see, another thing, before you start, you want to get yourself a power strip, and the key factor on there is you want to get one that's got an on-off switch on it, so that's how you can turn it on and off. You don't want to be unplugging and plugging in your power supply, because they'll just wear out the cords, and they don't give you an on-off switch on the power supply. In fact, that's one of the later upgrades that a lot of people do. But you could just go this route, get yourself a power strip. This just is kind of a odd looking one. It rolls up, but highly recommend a power strip with an on-off switch, and that will make life much easier for you. Okay, so next, I'm gonna, after that's out of the preliminary, that's out of the way, I am going to, we'll start with the power supply, and then switch over to the motherboard. The power supply connects right there in the corner, so it's kind of convenient, and we'll just start talking about the power supply, and then work our way around the motherboard, and I'll discuss every component, how you hook it up, and then how you test them out. I'll be right back. First component we're going to discuss is the power supply, and the very first thing you want to do is come over to the side, and there's a sticker, and it says 110 or 220 volts, and you just reach in there with like a little screwdriver and you flip that over to the appropriate voltage setting for your area. If you live in the United States, it's most likely going to be 110, unless you have a different situation in which you should already know about that, but the 110 standard for the United States. So then coming over here, the next thing I would recommend is you want to put crimps on your ends, But even before you do that, what you want to do is take your meter. Now this is kind of a British or European standard, and the color coding on this. So that's why the color coding is kind of funny. So it goes brown, blue, yellow, and they're using. Let me show you something first. Every power supply is going to be a little bit different because they keep modding these. My power supply, I think, is one of the better ones as far as the way that it's laid out. You'll see that it says L, that stands for, I believe, load. N is for neutral, and then they just have a ground symbol there. So you got 3 there, and then there's 3 negative voltages. See, 1, 2, 3, and then 3 positive voltages. So going the other direction, that's 3 positives, 3 negatives, so that's 6 pins, and then the load, neutral, and a ground. So that's a total of 9 pins, and if you count the screws, there's 3 right there, 2 blanks, 2 more, and 2 more. So there's 9 screw terminals that match up with those stickers. So you want to get an continuity meter or an ohm meter, however you want to do it. And you want to start with, I would start with the ground because that's easy. So the yellow one's supposed to be a ground. You just take that and them on your plug, which I already have plugged in. Here, I'll pull it out and show you what it looks like. On a plug, this round one right here on the bottom is your ground. And so you just take your ohm meter or your continuity checker, however you're using it, depends on your meter, and then you'd make sure that the 2 cable ends ohm out. And you want to do this is all with the power off, of course. Everything we've discussed from up to this point, your power's off. Then the load, we'll just go the right to left. So next would be the neutral. And your neutrals typically, if you look at sorry about that, if you look at a prong, or better yet, if you look at a power strip, or a wall plug or anything, see the round one on the bottom is going to be your neutral. The is the ground, and the whitest blade is your neutral, and it's usually on your left side, and the smaller blade is your I call it your power or your load, and it's going to be on the right hand side and it's smaller. So looking at your prong, you can see how you'd plug it in to determine which blade goes where, because oftentimes the prongs are the same and not bigger or smaller. And essentially what you want to do is just make sure that each wire goes to the appropriate thing, and that's a double verification that your color coding is correct. So so basically you want to make sure your load and your neutrals are going to the correct pins there. And so once you got that crimped on, then you're ready to test it out. You can wire it up, and then you'd plug in your cord. And I'm not going to turn this on for safety reasons. But then what you'd want to do is turn on your power strip, and then you'd want to test your put your voltmeter on and check out your voltages for the negative, positive. And if you don't have a voltmeter, you can watch videos on how to do that, because you can hurt yourself if you do stuff wrong on it. So I don't want to go into that, but you want to check your voltages and make sure your negatives are negatives and your positives are positives, and you're getting 12 volts. 12 volts on the ones that say V plus and minus. And so that at that point you know that your power supply is working, because your input power supply is going to be 110 volts AC, and then it's going to come out on those V's as 12 or between 12 and 13 volts DC, and the negatives are the V minuses and the positives are the V pluses. And there's 3 and 3. So then the next section, if that's all working, you'd turn off the power. Then you'd hook up your power leads, and my understanding is it doesn't matter which one you use. You just want to make sure you get a negative one and a positive one. So it really doesn't matter which one. Although Yeah, okay, so yeah, you just want to get a negative and a positive one, and I just chose the two center ones. It really doesn't matter which ones you choose, just so long as you got a negative one and a positive one. And then you take the other end of that and you go to your board. Now my board is different than most boards. I think I got the newest one. And if you look right there to the right, on, oops, where's my finger here? Right over on this side there's I believe it was negative, and on this side it's positive. We'll zoom in and take a look at that. See right there, there's a negative sign just to the right of those crimps, and a positive. And so that's how you tell which way to hook that up. And yeah, okay. And the lead that's negative does have, I believe, a little bit of red in it, but for the most part it's a black lead. Sorry about that, kind of wandering around on you. So just think of it as a black lead. You're seeing kind of a red stripe on top. That's why it kind of looks funny. Let me I'll kind of get right about here and show you that a little bit better. Hold on. So this has got a stripe on it. It's mostly black, and this one's solid red. And technically speaking, typically the striped one is considered your positive, but they made a red lead, so I'd recommend making the all red lead your positive lead and your black striped one your negative lead, just for consistencies. So at that point, I'm going to show you one thing about the board. Hold on, let me get in a different camera angle here. Okay, on my main controller board, if you look right down there, there's a tag, and I think that's how you identify this. It says A127U563. I don't know of other markings on the board, but hopefully that'll tell you. And the reason why that's kind of important is these connectors are going to be different on different boards that they made. So I got kind of like a square center post, screw-in post, and screw-in posts. And that's kind of the big difference between my board and most other boards. Also, something I want to say is these screws were on way tight, and so when I put my screwdriver in there and started turning it to the left, it wanted to turn the whole base. So you want to use your fingers and support that base when you're screwing and unscrewing those, because if you don't, it's going to twist and crack the solder joints on the bottom of the board. So you want to support those, and they had those on way too tight. And of course, and I recommend when you put them on, you just want to make them snug. You don't want to tighten them down so tight that it causes those bottom plates, the green bottom plates, to twist on the board, or else you crack those solder joints. So that should be it for the power supply. So we'll stop right here. Okay, the next part we're going to talk about is the extruder, and it's got 3 parts to the extruder. It's got the solid red wires, and they are used to heat the extruder, and there's a set of small white wires, and there I believe a temperature sensor, and then out the back side, let me flip it over, right here you have a stepper motor, and the wires are coming out for that up the top. Then swinging over to this end, I really wanted to put some kind of end on these, but I don't have an end for that type of wire. And the way I had to trim those back, they were cut flush, is I took an X-Acto knife and I just laid the wires flat, and I gently rolled over all the way around with the X-Acto knife, and then just slid off the casing cover. It's kind of like a highly insulated, almost like cloth-like material on the outside, and then very thin stranded wire on the inside. As you can see at the base down here, those are just Phillips screwdrivers. So you back those screws out, and then you can just put your wire in through the top and then tighten them down. So it's not a good design, but it works. So that's your main power supply there. Also, they're both red, so that's kind of an indication that they didn't care about polarity. So with that being said, then we'll move on to the next component out of this extruder, and that's going to be that temperature sensor. I believe it's a temperature sensor, and it goes those white leads, and we'll just trace those over, and they go right there. And it says ET, you can barely see it there, and it just plugs in. I should say two things here at this point. One is they give you a sheet that's very helpful, and right here you can see, hopefully that's showing up on camera, right there it says ET, and that's a pretty accurate representation. It says extruder, I think it says thermistor, so basically kind of get that right. So the next part of the extruder is the extruder stepper motor, and that goes up here in this corner. And if we look at the wiring on our extruder, see the stepper motor wires come out the top, and sure enough, if you follow them over, they just plug in there. I'm gonna just follow, on the ends of the wires they put tags on it, and that's really helpful, and I recommend sliding the tags. Mine were all the tags, well, they're kind of scattered. I was gonna say most of the time the tags were by the motherboard end, like these ones were, but not always. Like for instance, on the stepper motors, the tags were on the stepper motor side. The ends of the wires are different, so you can't put the wires in wrong, which was nice. I didn't have any trouble figuring out which wire. I want to show you, I'll show you on that extruder. I'm just going to zoom in on that one. I'm not going to plug any wires in. I'll just show you this one time. You see on this side of the wire, it's got that the little slots. The other side of that white wire connector on the right hand side is flat, and it matches the female connector that's labeled ET. And see, it's got grooves in it, so you can only plug it in one way. So don't force any of these connectors. If it's not going in, you probably got it backwards or you're looking at the wrong end. So they just slide right in. And they even kind of like clip in a little. There's a little bit slide and them clip, and that's how you know you have them in far enough. So I hope I'll show you the stepper motor. It's kind of hard to get a good position on it. There you go. And it's better just to look at that manual. And the stepper motor plugged in right there. And on the other side there's markings that says extruder stepper motor. Let me see what it says. I think it says extruder motor. Again, this paper is so much easier to read, and it's pretty accurate. It says on the motherboard, it's going to say E motor for extruder motor, and they did a good job about telling you what that is. So at this point, I'm not going to really go around, and I started thinking about it. There's not too much hardness on any other thing. The only thing I think I'm going to discuss next is your hot plate. And the rest of the components are just plug and play. What I mean like that is, if you go to your motor, the wire is hardwired into the motor. You can't do anything with that in, and you just look at your paper and see where it plugs in on the motherboard and plug it in. So that's virtually all the rest of the components are like that. Your stopper motors, they labeled them for you. Again, everything's got a sticker on it. And just use that sheet and go around and plug in all your components. The last one that's kind of weird is this hot plate. Now the hot plate, see it says plus and minus on there, and you got two skinny wires in the middle and two thick wires on the outside. The skinny wires are for monitoring, the thick wires is actually for heating. And I recommend on the hot plate, putting those connectors on, and again, support that green connector when you're loosening and tightening so you don't break the joints on the bottom. And they did not label these as to which one should be positive and which one should be negative. I'm going to go out on a limb and recommend everybody do it the way I did it. And the way I determined, because it's opposite this one here, the way I determined that that's how I wanted to power it up is I actually, when I got everything wired up, and we'll talk about that later, I turned on the board and said, hey, I want to heat up my hot plate without those wires hooked up. And then I put a volt ohm meter in it and determined on the board which one is sending negative voltage and which one is positive voltage. And that's how I determined which way I wanted to hook those wires up. And also, I was noticing they didn't, and I'm going to get a little electronics on you, they didn't tie down or tie up those connectors. They're what they call free floating. What that means is, if I turn on the board, they'll either be negative or positive or switched around. They're just kind of floating. They didn't nail them down until I go to use it, and then you'll get a definite, I think it was 12 volts or something, and it'll be the correct polarity. But before you use it, they're just kind of out there doing their own thing. So don't rely on it with the board on, but you're not powering those connectors to check the polarities on there. You need to have it actually done in there, and we'll go over that. So at this point, I'm going to finish up this part of the video. That should be enough information to tell you how to connect all your components, and that's where you should be about at this point. You hooked up all your different components, and you're ready to actually start testing. If you have any questions, leave them in the comments below.